So we're learning about circles today. We have a brand new packet. Does anybody ever hear the phrase locus of points? We used to do a whole section in geometry called locus of points. It means all the points that fit a condition. So if I said all the points 6 inches from the end of my finger, okay, what would I get? A circle if it was in a single plane. If it was three-dimensional, I'd get a sphere, right? So all the points the same distance from some center are what makes a circle. The distance around the outside is called the circumference. This is the center, radius. All those should sound familiar. Anybody know what that is? Slope? Please tell me it's not slope. Yes, good job, Brandon. It is distance. Now, we just said that all the points the same distance from the center, okay? What is that distance actually called here, though? How far from the center? It's called the radius. So if we change this to r, the radius is all the points the same distance Well, guess what? The equation of a circle does is they square both sides so that it says x minus x squared plus y minus y squared equals the radius squared. So they got rid of the square root over all this side. That's the equation of a circle. Comes from the distance formula because that's the definition of a circle. So write that down. Here, for what is the equation, the standard form of a circle right here? It is x minus some x value, which they will also call h, because they will say the center is h comma k, squared plus y minus some y value, guess what they're going to call the y value? K, squared equals r squared. And what does r stand for? Yes. Okay, so that's the standard form of a circle. Everybody good? Now, before we do the rest of this, let me revisit. I have a cute little app here. So when we have this equation, x squared plus y squared, where's the center, guys? 0, 0. And the radius? 16 is not, yeah, the radius is the square root of that, which is 4, right there. What happens when we do this one? X squared plus y squared equals 4. The radius will be 2, but it's at the same center. Now, this is going to move where? Anybody know? Almost up 2, because it's the opposite. So it's up 2, and the radius is 3. Okay? This one is going to move right and down, but it's going to be the same size circle as which one? The red one. Good job. To the right and down. All right, now what do you notice about this one? It's got a 3 out in front. This is the end of the lesson today. We're going to learn about a new thing. It's not a circle anymore. This is what's going to happen. Yes. It's going to be stretched. It's going to be called an ellipse. Okay? So that's for later today. It's a very exciting lesson. In case you haven't figured it out, Miss Abruzzo told all of her classes the only reason we do this unit is because it's Hofbauer's favorite. And that's not true, but it is one of my favorite. It's no trig, so if you've been like, with the trig, we have no trig for the next couple weeks, okay? All right. What is the equation for area of a circle? Anybody remember area of a circle? No. Pi r squared. Circumference of a circle. It's just 2 pi r. Or you could say, what's 2 times the radius called? So it's pi times diameter. You have to use these later because it will give you like, it'll tell you the circumference of some circle is 7 pi, and you have to find the equation of the circle. So you have to pull out the diameter or the radius or whatever and figure it out, okay? Everybody got those? Martin, are you doing this? This is the new packet. We good? Okay, you might have to get it from someone else if you didn't get it yet. All right, guys, tell me where the center is. Yes, 2, -3. It is the opposite of what's in here because the formula was x minus h and y minus k. And the radius squared is 4, so our radius is 2. Do we have to worry about a plus or minus? No, because it's a distance, so it can only be positive. So we're supposed to graph this, and we'll see who draws circles well. It won't be me, I promise. 2 to the right, down 3. No. Now, tell me, if the radius is 2, what should I do? Okay. Every direction, meaning straight up, straight to the left, straight down, and straight to the right, and then connect them. It does not go through exact ordered pairs in between. Oh my goodness. Okay, that one's not horrid. I'll go with it. Give me a little credit. Moving on. Yeah, I know. Okay, tell me what's going on here. Where's the center? We got to get through this. -1, 0, and the radius is 6. So from -1, it goes over to 7. From -1 this way, it would go 6 units would be +5. And because that is so big, I am going to take Martin's suggestion. Is there a circle? Where's the circle? There we go. There we go. 2. I can't even make it work with the circle tool. Okay, there we go. Everybody good? So you could do those on a quiz? Okay, now we're supposed to write the equation. So what would it look like if the center was at 4, 6, and the radius was 9? Yes, because this is the radius, so you still have to square it. I know it gets a little confusing when it's a perfect square already, right? All right, I hate to tell you this, but this is where it gets a little trickier, and you got to be able to do these. It gets even meaner on the quiz, so hang on. This is h and k. We could use the distance formula, but I'm going to teach you to cheat, okay? So we're going to go x minus what, or plus what? The center, so plus 15. And then y minus 3 quantity squared equals r squared, right? But to finish, we need to figure out what r is. But if this is a point on the circle, where could I put those numbers in? Yes, Destiny. I could put this in for x and this in for y. So I'll have -15 plus 15 plus -1 minus 3. Be careful. This is 0, but this is -4 squared, which becomes positive 16. Now, do we need to square root? We could, but we really don't need to, because what is the equation supposed to have in it up here? An r squared. So final answer? Equals 16. If you square root it, you got to remember to square it again. All right, everybody good? All right, so that was an important thing. Now, we're going to write this, x minus 7 quantity squared plus y minus 1 quantity squared equals what? 16. Now, we want to write it in what's called general conic form, and they do this on the SAT all the time. They put things in weird forms. In other words, they FOIL it all out. Okay, we're only going to do one. X minus 7 times x minus 7, anybody? X squared minus 7x and minus another 7x would be minus 14x plus 49. Good call. Okay, back here we have y minus 1 times y minus 1. Anybody got me there? And then we get it equals, on this side we had a 16. All right, general conic form puts all the squared terms, I believe, first. Then all the non-squared, so we'd have like minus 14x and a minus 2y. And then we're going to move all the constants to the other side, or they make it equal to 0, I'm not really sure. I'm going to subtract the 49 and the 1 over to the other side. Someone help me. 34 negative? Okay, not positive, but that might be what they would write for general conic form. No. The reason I did this, I'm not going to make you do this, okay? The reason I did this is because you're going to have to go the other direction. You're going to have to complete the square. Yes, this is completing the square the other direction. So now what we're going to do is practice completing the square. Oh, it looks like they would have made it equal to 0. By according to the next one, they would have been plus equals 0. This is what they would have called general conic form, okay? So this one is in general conic form, and we're supposed to write it in standard form and then find the center and radius. 16 minus 49 minus 1 is negative 34, but if we added it back over to this side so that it equals 0, I'm still combining the like terms. Good question, because I went by that really fast. Not going to ask you that on a quiz, but I want you to think about what we did and how can we make this go the other direction. Get the x's together, good call. And I'm going to put a little blank in here because remember there was a number there. Then what? Plus another number was in there, right? And then it was equal to, what are we going to move to the other side? Yes, be very careful because that's where the first big mistake will be, is you'll forget to change the sign and then you're messed up the whole rest of the way. All right, completing the square. What's the rule? You do what to this? You take half. So you square root the x squared and get an x, and then you take half of 15, or 30, half of 30 and get 15, sorry. And then you do what to it up here? Square it, it becomes 15 squared, or 225. And I have to add that to this side. All right, so that was the only giveaway for the day. I want you guys to tell me how to do this one. Y. Be very careful. Yes, it's a negative 2, so when you take half, it's minus 1. And then you square it. Negative 1 times negative 1 is 1, and whatever you add to that side. Okay. So over here, I end up with, I think, 4. Okay, is that standard form? There's a beautiful thing. Where is the center? Good job. Negative 15, 1. And the radius is? This is the radius squared. So the radius is 2, not negative 2. Why did it look like I wrote negative 2? The radius is 2. So it's a tiny little circle way off to the left at negative 15. And up 1, okay? Any questions? All right, we're going to practice one more time, or you are. Can you beat me? Can you beat me? I don't have a calculator, so. Did anyone get a 5? Okay. And actually there is, I think the one on the quiz doesn't come out nice. So, it's all right. What is the center? -15. I got +16. Yes? Everybody good on the signs? Did I mess up the signs? Everybody okay, or did I mess something up? All right, and then this is r squared. So the radius is actually the square root of 5, which is, you can leave it that. If I had to graph it, anybody give me a decimal? 2 point something? 2.24? If I was graphing, a little more than 2 would be all I could graph, right? You can't be very accurate when I'm graphing, but just gives me an idea. Everybody okay? All right, you got to be really good at, we're going to do a lot of completing the square this entire unit. All right, this one looks bad because it's really leading into what's going to happen in the next one. If we have 4x squared minus 96x, I'm not even bothered with the blank, plus 4y squared minus 12y equals, I'm going to move that 441 over to the other side. Yeah, negative 441. Does this divide by 4, 441? Okay, well, we're still going to have to divide it. Okay, if we divide everything, it just so happens that 4 divides all of these. You know what? I'm not going to do it this way. Give me a second. No, I'm not going to erase anything. I'm just going to take the 4 out of these two and make it x squared minus, somebody help me, 1, 20, 20, 24, and then put your blank in the parenthesis, okay? Now the y's, I'm also going to take out a 4, and it'll be careful, minus 3y plus blank equals, and then over here I have the negative 441 plus a green blank and a red blank. Okay, this is leading into what we're going to do a million times tomorrow. We're going to do x minus, there's still a 4 out front, okay? What is half of this? When you square 12, you get 44. Now, I don't put 144 on the other side. Does anybody know why? Yes, because there's 444s there. I'm just going to write 4 times 144 over here, because I think that would help you in your notes later to know where that number came from. Does that make sense? And then back here, we have a 4 out in front. And what is half of 3? Yeah, 3 halves. Okay, square the top and the bottom. 9/4. It's not as bad as it looks, guys. Square the top, square the bottom. Everybody good? Then when you multiply by 4, you actually get what? Yes, or in my little red blank is a 4 times 9/4, which is just 9. All right, so now on my calculator, I'm typing negative 441 plus 4 times 144 plus 9. And I get? Anybody else get that? Okay, now what? Eventually, we would think of this as an ellipse, but because there's a 4 in front of both of them, we can actually divide the 4 out now. If we divide the 4 out here, and here, and here, this is going to be x minus 12 squared. This is going to be y minus 3/2 squared. Lovely. And 144 divided by 4 is 36. Okay. So it is a circle. What's going to happen when we do ellipses is like this one might have a 4 in front, but this one might have a 10 in front. So it's stretched one way more than the other. All right, it's cool. It's cool. So are we supposed to maybe list the center would be at 12, 3/2, and the radius would be 6? All right, moving on. Okay, this is the one I'm a little worried about because this is on the quiz. It's the only one I'm worried about because the rest I think you're going to knock out of the park. Over 0, down 2, and over 12 and up 4 somewhere over here. Yes! Destiny's all about it. If this is the diameter, the center of the circle is somewhere at the midpoint. Okay? Midpoint is easier. Do you remember how you do midpoint? Average the x's and average the y's. And how do you average two numbers? Yes. X plus x divided by 2. Y plus y divided by 2. So what is our midpoint here? 0 plus negative 12 and negative 2 plus 4. Midpoint is at negative 6 and 1. You do have to add before you divide by 2, so don't type it in without parentheses, or just use your brain. Add and you get negative 12, divided by 2 is negative 6. Add and you get 2, divided by 2 is 1. Everybody good? So write that out, what we have so far. We know the equation of the circle is x, what? Because this is the center. X plus 6, quantity squared, plus y minus 1, quantity squared, equals r squared. I don't know why I decided to write it on top of the other, but okay. Does anybody remember earlier, like 5 minutes ago, we put in one of these rather than trying to, yes, what I should tell you have to do is now find the diameter by using the distance formula, cut it in half, that'll give you the radius, and then square it and plug it in here. I don't want to do that. There's a way easier way. We know the center, we already put it in. But doesn't this circle go through both of these points? So you can put in either one to find the radius. Which one would you like me to put in? Okay, let's put in 0 here. And negative 2 back here. And solve for r squared. We don't even need r, we just need r squared. What does this become? And this would be negative 3 squared would be 9, right? So we get 45, which is not a nice perfect square, but doesn't matter because we just wanted the equation. What is the equation of this circle? Final answer, x plus 6 quantity squared plus y minus 1 quantity squared equals 45. Much easier if you just plug in an x and a y. And why did that work again? Because if we know the ends of the diameter, once we find the center, that was the midpoint, right? And then from the center to the either of those endpoints is a radius, yes? Okay. There, Mr. Brusso said this wasn't on here, but it's on the homework. Oh, you don't have this one? Oh, well, I'll do it real quick. What's the formula for area? Okay, this, I might have just changed the notes, but it's on the homework. This is pi r squared, so how do you find this? You divide the pi off each side, you have r squared is 100, so r is 10. So now could you write the equation? Everybody good? Okay. All right, I'm gonna skip this one. Do you have this one? What's on the back?
R14 says x minus 5 quantity squared plus y minus 7 quantity squared equals 16. That's where R14 says. Well, on the side anyway. Our notes are already over.
Oh, the notes are done?
Yeah.
Okay, so I'm just moving on. This is what you're supposed to do tonight is on worksheet 2, okay? Everybody good? Now we're gonna have a fun time starting something new about ellipses before we finish today. Okay, did everybody get the peach sheet at the back? Was it pink? Yours was pink. Mine is peach for quiz purposes. It's pink. Okay, everybody got a pink reference sheet? All right, find ellipses on there. It's all the little ovals. Did you find them?
Yeah.
Okay, so standard form for an ellipse. Well, an ellipse is made by doing this. Okay, so I'm gonna not pause the video and try to yell really loud from across the room. Okay. Yeah. So if I take these two pieces of tape and I put them right on top of each other, and I put my pencil in here, what is this going to draw?
A circle.
A circle. And what is that string going to be?
The radius.
The radius of the circle, right?
That's right.
Good?
Yeah.
So it's actually the whole length of the string is 2 radiuses, or the diameter.
Yeah.
All right. What we're going to learn about today is what happens when you take the ends of the string and you move them apart. So if I move the end of the string over here, and I put my pen in, and I draw this, it still looks a lot like a circle, but it's actually a little bit squished. What happens, though, is if you move them very far apart, you get a lot more of squish, and you end up with an ellipse. Okay? So, the definition of an ellipse is a shape where this string stays the same length. So in a minute, we're going to talk about what's called focus points. Where do you think the focus points are here? Look up here. Where are there 2 important points I was using?
Those two.
The end of this and this. Those are called the focus points, okay? When you move those further apart, you get a more stretched circle. Now, could I move them this way? Yeah. And I moved them really far apart, so I'm going to get probably. Okay? So those 2 points are very important. They're called focus points. All right. Here we go. So the fancy definition that you don't ever have to quote for me is that this total length of string, or D1 plus D2, has to equal be equal all the way around. All right, when you start drawing these and you squish it out this way, the longer axis and the shorter axis have different names because you've squished it, okay? So one is to be called the major and one's to be called the minor. Does that seem okay? All right. There's still a center. Now, where do you think those focus points are going to be? Yes, they are always on the major axis. Does that make sense from when we were drawing up there? Okay. Now, this book, some books call all of the ends here out. Let me do them green. All of these ends out here, some books just call them vertices. Our books say there's vertices here and here, the ends of the major axis, and then they call these co-vertices. They're not quite as important, I guess, okay? Because they're the minor axis. You just learned everything that we need to know. All right. Now, the difference here and here, once we start using this reference sheet, students tend to struggle when we learn, because it's very different if it's an ellipse than a hyperbola. I think on yours, there's a little box over here. What does it say in that little box? It says A is always greater than B, okay? So when the bigger number is under the X, guess which way it stretches? The major axis runs like an X-axis, okay? When the bigger number is under the Y, then the bigger stretch is up and down like the Y. Does that make sense? Okay. So before we go any further, we are going to look at this example. That one's done for you, actually. I'm going to skip to this one. Oh, this is a really easy little baby one. So where's the center here, guys? I don't know what worksheet am I on. What worksheet am I on? 5A? Did you find 5A? Yeah, 5A, bottom. Thank you. The center is not shifted here. There's no shifting, so the center is at 0, 0. Okay. Now, this number is bigger, so it's called A, and A squared is 16. This guy is B because he's smaller, so B squared is 9. What does that tell me? Anybody think they can figure that out? A is 4 and B is 3. Very good. Okay, A was underneath Y, so we're going to go 4 units which way? Up and down because of it's under a Y. So now this graph paper is counting by 2s, so 2, 4. There's -4, +4 up there. And in the X direction, B is 3, so we're going to go out 3 units this way and 3 units this way, which is a little bit less than 4 right there. Yeah, I don't know why they had to count by 2s, but okay, so it shouldn't look circular, it should look a little bit stretched. Now, when you are doing these, you are going to have to state, let me go back. Hang on. You are going to have to tell me the center, the foci, the vertices, and the co-vertices, okay? You have to be able to tell me all 4 of those things. You do not have to state an equation for the major or minor axis, but you do have to know how to find, look, the focus is C, right? You have to know how to find C. C, the calculation to find C is a weird Pythagorean theorem. Instead of a squared plus b squared, it's a squared minus b squared. What that does is it brings the focus inside of the ellipse. If you were to add, it would be outside, and then it would be a hyperbola. So, now I'm going to talk about this conceptually, There is a formula there on your sheet, but where did we find the vertices, guys? This is the major axis was going up and down, right? Because the bigger number was under there. So how did we get up here? We went up and down 4 from 0, 0. So the vertices were at over 0, up 4, and over 0, down 4, right? The co-vertices are at the other end. And how far did we go out there? 3 for B. So 3, 0, and negative 3, 0 in any order. And the last thing we have to find are the foci. The foci should be on that major axis. The distance they are out is C, and C squared equals A squared minus B squared. So what numbers are we putting in there? 16 minus 9, which is 7 on a good day. So C is the square root of 7, which I'm going to leave exact for the ordered pair, but can anybody tell me what the square root of 7 would be about? 2.5-ish? What is it? So 2.7-ish. So it's almost to 3. So it's right inside there. Okay. I don't care if you don't draw them very accurately on your graph, but we have to name them over here. So the foci are at 0 up the square root of 7 and 0 down or negative square root of 7. Do you have to graph those? Is that your question? I'm not going to be real picky about graphing them so much as if you graph them, it will help you check where they land, and they need to land inside of it. If they land outside, you did a calculation wrong, okay? So tomorrow we're going to pick up here, and we're going to start talking about when they're shifted, that brings a whole nother bit of chaos into this, okay? So tomorrow we're going to do all kinds of fun with ellipses. So your only homework tonight, guys, is to get all this circle stuff done. Can you do that?